geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A particle of mass m is projected with a velocity u, making an angle of 30 degrees with the horizontal. Given angle of projection theta equal to 30 degrees. The magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height. What is the angular momentum about its point of projection when the particle is available at the maximum height? Okay, it is like this. Look at the projectile motion, right? Look at the projectile motion. Here, particle is moving with a velocity u, is making an angle theta. Look at the theta value, 30 degrees. Theta value given 30 degrees. And that projectile is maintaining the mass m. Okay. It is asking what is the angular momentum about its point of projection. Point of projection is 0 when the particle is at its maximum height. Look at the maximum height. This is the maximum height. Maximum height point. Okay. Where the maximum height h max equal to u square sin square theta by 2g. At that maximum height, as we all know, the projectile is maintaining only horizontal component of velocity, that is ux equal to u cos theta. Then angular momentum about the point of projection, that is o, angular angular momentum about the point of projection, point of projection equal to mass of the projectile into horizontal component of velocity into maximum height. Maximum height. Okay. It is equal to mass into, or the horizontal component of velocity, u cos theta into maximum height is u square sin square theta by 2. You simplify it. It is equal to m into u cube into cos theta into sin square theta by 2g. It is equal to mu cube by 2g cos theta, cos 30 degrees into sin square 30 degrees. Simplify it. It is equal to mu cube by 2g into cos theta, cos 30 equal to root 3 by 2 into sin 30 1 by 2, 1 by 2 square. 1 by 2 square I can write directly 1 by 4. 1 by 4. Now simplify. 4 into 2, 8. 8 into 16. M u cube into root 3 by 16g. That is the answer. M u cube root 3 by 16g. Look at the options. Okay, option A may be printing mistake. It is 16g. Option A is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at this problem. Asking like this. A body is thrown with a velocity of 9.8 meter per second, making an angle of 30 degrees with the horizontal. It will hit the ground after a time. It will hit the ground after a time t equal to time of flight. As you know, time of flight, t equal to 2u sin theta by g. It is equal to 2 into U value given. Look at the U value given 9.8 meter per second. Right? Of course, theta is given 30 degrees. So 9.8 into sine 30. Listen carefully. Sine 30 degrees divided by G 9.8. This 9.8, 9.8 cancel. Finally, it is 2 into sine 30, 1 by 2. Right? 2 into 1 by 2 equal to 1 second. That means the body is hitting the ground in 1 second only. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. Look at the problem asking like this. A projectile is projected at 30 degrees from the horizontal with initial velocity of 40 meter per second. Angle of projection theta is given 30 degrees. Initial velocity u is 40 meter per second. The velocity of the projectile at t equal to 2 seconds from the start will be. What is the velocity of the projectile? Velocity of projectile. Velocity of projectile after t equal to 2 seconds. Okay. Given acceleration due to gravity 10 meter per second square. For that, first let us decide time of flight. Time of flight equal to 2u sine theta by 2u sine theta by g. It is equal to 2 into u40 sine 30 degrees divided by g 10. It is equal to 80 into sine 30 1 by 2 1 by 2 by 10. So it is equal to 4 seconds. The time of flight is 4 seconds. Since the time of flight is 4 seconds, right? Time of ascent equal to time of descent, that is equal to 2 seconds. Okay. Then indirectly it is asking what is the velocity of the projectile, right? When it is completing the time of ascent. By the time of ascent is completing, the projectile is reached to the maximum height. Look at the right diagram. So look at the right diagram. This is the theta given 30 degrees, u given 40 meter per second, right? Here the horizontal range is r. The time of flight we decided 4 seconds. Then it is asking what is the velocity when the time projection equal to 2 seconds, right? So this is the time of ascent t1 equal to 2 seconds, time of descent t2 equal to 2 seconds, then time of flight equal to time of ascent plus time of descent equal to 4 seconds. That means the particle can be reached to the highest point in 2 seconds. At the highest point, vertical component velocity uy equal to 0. It is having only horizontal component velocity ux, that is equal to u cos theta. Therefore, the velocity of the projectile after 2 seconds equal to, only it is having horizontal component velocity u cos theta. U is 40 cos theta, cos 30 degrees, cos 30 degrees. It is equal to 40 into root 3 by 2. It is equal to 20 root 3. 20 root 3. That is the answer, right? 20 root 3. Look at the options. Option A is absolutely correct. Understood clearly? Yes.
Geobyte.